Hi dear students, already 9 questions are completed in bond order, bond angles. Next question, in which of the following ionization processes the bond energy increases and the magnetic behavior changes from paramagnetic to diamagnetic? Paramagnetic means if unpaired electron is present, that is paramagnetic. If there is no unpaired electrons, diamagnetic. So first, magnetic behavior changes and bond energy increases. If we observe O2, so NO, how many electrons? Nitrogen 7, oxygen 8, 7 plus 8, 15 electrons. Next, NO plus nitrogen 7, oxygen 8, 7 plus 8, 15, 15 minus 1, 15 minus 1, plus means minus 1, 14 electrons. If 14 electrons, bond order is, we know that the shortcut, for 14 electrons bond order is 3, 15 electrons bond order is 2.5. So when you write MOED order of NO, MOED of NO, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, transmits sigma 2pz, pi 2p, sigma 2px2, pi 2py2, pi 2pz2, 2, 4, 6, 8, 10, 12, 14. Next pi star 2py1. So one unpaired electron is present. So NO is paramagnetic. If one unpaired electron is present, that is paramagnetic. Next 14 electrons. For NO plus, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Next pi 2px2, pi 2py2, sigma 2pz2, 2, 4, 6, 8, 10, 12, 14. So 14 electrons are present. No unpaired electrons. No unpaired electrons. So no unpaired electrons means diamagnetic. So it is dia, para. So para is converted to dia, paramagnetic to diamagnetic. Next 15 electrons are converted to 14 electrons. For 15 electrons means bond order is equal to 2.5. 14 electrons means bond order 3. So 2.5 to 3, bond order increases. So bond order is directly proportional to bond energy. So answer NO to NO plus. So remaining also you check. Next question. Arrange the following spaces in the correct order of their stabilities. Correct order of their stabilities. Bond order is directly proportional to stability. When number of bonds between any two atoms increases, stability also increases. So like that, if you take Ne2 does not exist because it is noble gas, does not exist. So bond order 0. Bond order 0. Next, O2 minus 2. O2 minus 2 means 16 plus 2, 18 electrons. 18 electrons, bond order 18 electrons, bond order 1. C2, 12 electrons. 12 electrons means bond order 2. So next O2 minus 2 completed, N2 minus. So 14 plus 1, 15 electrons. For 15 electrons, 14 electrons bond order 3, 15 electrons, so 0.5 decreases, so 2.5. So write the increasing in the correct order of their stabilities. So increasing of bond order, so higher one is N2 minus. So next C2, so next one O2 minus 2, finally Ne2. So answer Ne2, O2 minus 2, C2, N2 minus. So answer A. So note this. If you know the bond order is directly proportional to stability. So note this one. Next question. The correct order of bond angles of the following is. So bond angles, very easy to find out. First H2O. So it has angular structure. The hybridization is sp3. Angular structure. The central atom has 2 lone pairs. So what is the angle? If the hybridization is sp3, the bond angle 109 degrees 28 minutes. But due to the presence of 2 lone pairs, according to VSEPR theory, lone pair repulsions are more than the lone pair bond pair repulsions than the bond pair repulsions. Due to the lone pair repulsions, bond angle decreases from 109 degrees 28 minutes to 104.5 degrees. So more bond angle decreases. If you take NH3, in NH3 the central atom nitrogen, the shape is pyramidal shape, 1 lone pair is present. So due to it is also sp3 hybridization. H2O sp3 hybridization, in NH3 nitrogen undergoes sp3 hybridization. Due to the presence of lone pair bond pair repulsions are more than the bond pair repulsions. Due to this, the bond angle decreases from 109 degrees 28 minutes to 107 degrees. When compared to this one, this bond angle is very less. Here lone pair repulsions are more. Here only lone pair bond pair repulsions are there. So second one NH3 completed. Third one CH4 methane. So it has tetrahedral sp3 hybridization central atom. There is no lone pairs, so bond angle 109 degrees 28 minutes. So last one SO2, S double bond O. Sulfur has 1 lone pair. So angular shape bond angle, actually bond angle SO2 bond angle sp2 hybridization bond angle 120 degrees. Due to the presence of 1 lone pair, it is less than 120 degrees, nearly 119 degrees or 118 degrees are present. So according to this, which one has the highest bond angle? 119 degrees. That means SO2 has the highest bond angle. That means 4. 4 is greater than the remaining. So maybe answer A and B. A or B. Next, after 119 degrees, 109 degrees 28 minutes. That means 3. 4 greater than 3. So option A or option B. Next one 107 degrees. So option 4, 3, 2. Next finally 104.5 degrees. So 1. So 4, 3, 2, 1. Next question. The number of 120 degree angle CL angles in PCl5 are PCl5 hybridization sp3d. PCl5 the central atom phosphorus undergoes sp3d hybridization. 3 chlorine atoms are present in equatorial plane. 2 PCl bonds are axial bonds. That means 2 chlorine atoms are in axial position. 3 chlorine atoms are present in equatorial position. So the equatorial bond angle is 120 degrees. Either these PCl2 bonds or these PCl2 bonds bond angle 120 degrees. Axial and equatorial bond angle is 90 degrees. Axial bond angle is 180 degrees. So Cl angles in PCl5, the number of 120 degrees. So it is 1, next it is 2, it is 3. So total 3 Cl bond angles are present. So 120 degrees 3 Cl. 90 degrees how many? It is 1, it is 2, it is 3. Again these 1, 2, 3, 6. 6 PCl bonds are 90 degrees. 6 PCl means 6 ClPCl bonds are 90 degrees. 3 ClPCl bonds are 120 degrees. 1 ClPCl bond is 180 degrees. So very important. So answer 3. Next, which among the following represents the correct order of variation of bond angles in the given molecules? Again, bond angles, correct order. NH3, NF3, PCl3, BF3. NH3, the shape of NH3 molecule is pyramidal shape. Next, NF3, it is also pyramidal shape. So next, PCl3, it is also pyramidal shape, so one lone pair. Next, BF3, it has trigonal planar structure. The bond angle of BF3 is 120 degrees. We know that in NH3, due to the lone pair bond pair repulsions, the bond angle is 107 degrees. It is decreases from 109 degrees 28 minutes to 107 degrees. Next, in NF3, due to the presence of more electronegative atoms, the bonding angle some more decreases, so nearly 102 degrees. In PCl bonds, when compared to nitrogen phosphorus, electronegativity less. When electronegativity decreases, bond angle decreases. So here nearly 100 degrees or 99.8 degrees. So what is the answer? Which one is the highest? BF3 is the highest. So answer B, C or D. Next one is 107. That means NH3. After BF3, NH3. So C or D. After NH3, NF3. BF3, NH3 and NF3. So option D. So very important one. Not this. So next question is 15. Hybridization concept. First, how to find the hybridization of the molecules? How to find the hybridization of the molecule? One of the formula, hybridization is equal to half into V plus M minus C plus A. Here V means number of valence electrons. Already I gave the formula of this hybridization. So hybridization is equal to half into V plus M minus C plus A means V means number of valence electrons, number of monovalent atoms, cation charge, anion charge. So I3 minus means the central atom is iodine. So half into central atom iodine. How many valence electrons are present in iodine? Iodine 7th A group element. So valence electrons are 7 plus number of monovalent atoms. How many surrounded atoms? If the middle of the atom is I, the surrounded atoms are 2. So 2. So it is I3 minus. So 2 surrounded atoms are present. So monovalent atoms 2. If any charge is present, anion is present, so plus 1. So 7 plus 2, 9, 9 plus 1, 10, 10 by 2. 10 by 2 means 5. 5 means hybridization sp3d. So 1s, 3p, 1d. So total sp3d hybridization. Second one, ClF3. If sp3d hybridization, the shape is without lone pairs trigonal bipyramidal, but with lone pairs the shape of the iodine is linear. So I3 minus is linear. So next, ClF3, the central atom is chlorine, half into chlorine, number of valence electrons 7, number of monovalent atoms 3, there is no charges, so 10 by 2, 5. Again hybridization sp3d, but the shape of ClF3 is ClF. First high electronegative atoms are occupied at axial position, so the remaining fluorine is fluorine is present on the equatorial plane. Two lone pairs are at equatorial plane. Lone pairs always occupied at equatorial plane. There is no occupying at axial position. So its shape is T shape. So ClF3 shape is T shape. Next, H2O. Oxygen central atom. Oxygen number of valence electrons is 6. Number of monovalent atoms hydrogens 2. 6 plus 2 8 by 2. 8 by 2 means 4. So hybridization is sp3. The shape is H2O. Actual sp3 hybridization shape is tetrahedral, but due to the presence of two lone pairs at oxygen atom, its shape is angular. So like this. So angular. H2O shape is angular. Next, SF4. The central atom sulfur. So half into sulfur number of valence electrons. Sulfur which group? 6th group 6 plus number of monovalent atoms 4. 6 plus 4 by 2. 10 by 2. 10 by 2 means 5. The hybridization is sp3d. Its shape actually trigonal bipyramidal, but due to the presence of one lone pair at sulfur, the shape is seesaw structure. So options are not given. So answer SF4 structure seesaw. So next question, match the following DsP2, sp3. If DsP2 means hybridization, DsP2 means square planar. So next, sp3 hybridization means tetrahedral. sp3 hybrid, D to sp3 means octa. sp3d hybridization means trigonal bipyramidal. So it is a direct bit. If sp3 hybridization tetrahedral, sp2 is trigonal planar, sp means linear. So next question. You see the next question, the shapes of XCF2, XCF4 and XCO3 respectively. So no need to calculate like this hybridization, that is your choice. Based on this formula, you calculate the hybridization of the central atoms, or otherwise Xe means how many electrons? 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. How many surrounded atoms are? Fluorine 2. So here one fluorine atom, here one fluorine atom. So two bonds are directly attached to the xenon atom. The remaining 6 electrons are 3 lone pairs. So 2 bond pairs, 3 lone pairs. The hybridization is sp3d. sp3d hybridization. But only 2 bond pairs. The structure is XeF2. So remaining lone pairs are at equatorial plane. So the shape, what is the shape? Linear. So XeF2 shape is linear. Second one, XeF4. So again 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons at xenon. So 4 fluorines. 4 fluorines forms 4 bonds. So remaining 2 lone pairs. So the shape of the molecule is XeF4. 4 fluorine atoms at square planar manner. So remaining 2 lone pairs are above the plane and below the plane. So it is square planar. The shape of the molecule is square planar. XeF4 square planar structure. XeF4. Next, the third one, XeO3. 1, 2, XeO3, Xe 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons. O3 means oxygen forms 2 bonds. So double bond O, double bond O, double bond O. So 1 lone pair. 3 bond pairs, 1 lone pair. The hybridization sp3 hybridization. 3 bond pairs, 1 lone pair. So XeO3, 1 lone pair. Its structure is pyramidal. So pyramidal shape. So So what are the shapes of the XCF2, XCF4 and XCO3? XCF2 is linear, XCF4 is square planar, XCO3 is pyramidal shape. So based on electron pairs arrangement also you calculate the hybridization. Okay. The geometry and dipole moment of H2S respectively. Geometry means shape of the molecule and dipole moment either non-zero or zero. Mu is equal to 0 or non-zero. So first geometry of H2S. Sulfur, how many valence electrons? Sulfur valence electrons are 6th group, 1, 2, 3, 4, 5, 6. So 2 hydrogens forms 2 bonds. So remaining 2 lone pairs. So if any molecule contains a lone pair of electrons, that molecule has dipole moment. That means mu is non-zero. So first it has 2 lone pairs. Mu value is non-zero, not equal to 0. So non-zero means not equal to 0. Next it has H2S. H2S shape is due to the presence of 2 lone pair of electrons. So shape is like this. So angular shape. Next mu is non-zero. So angular and non-zero. So answer A. Next, the types of hybridization on 5 carbon atoms left to right in pent, 1 in 4-ine. Pent means 5 carbon atoms. 1, 2, 3, 4, 5. Pent 1, 2, 3, 4, 5. 5 carbon atoms. 1 in first position in double bond. 4-ine 2, 1, 2, 3, 4, 5. 4-ine means triple bond. So 1 in 4-ine. So remaining hydrogens. Here already 2 bonds are there, remaining 2 hydrogens. Here 3 bonds are present, remaining 1 hydrogen. Already 2 bonds are there, 2 hydrogens. 4 bonds satisfied because carbon valency 4. So already 3 bonds are there, remaining 1 hydrogen. So first hybridization, left to right. Double bond is present, sp2. Again double bond is present, sp2 hybridization. Both are single bonds, hybridization sp3. Triple bond is present, sp. Again triple bond, sp. If any one side triple bond is present, sp. If any one side double bond is present, sp2. The hybridizations are sp2, sp2, sp3, sp. Okay. Next question. Which of the following molecules has only one lone pair of electrons on their respective central atoms? First one, SO2. Sulfur, how many valence electrons? 6. 1, 2, 3, 4, 5, 6. 2 oxygen atoms forms 4 bonds. So it is one lone pair. So it has one lone pair. Next, second one, XeF4. Xenon central atom, 18th group element. That means 8th group element. 8th group element means 8 valence electrons. Very easy. 1, 2, 3, 4, 5, 6, 7, 8. The group number means number of valence electrons. So 18th group or 8th group has number of valence electrons 8. 4 fluorine atoms forms 4 bonds. 1, 2, 3, 4. So remaining 4 electrons are 2 lone pairs. So it has 2 lone pairs. Next, PbCl2. The central atom is Pb. Pb which group? Carbon, silicon, germanium, tin, lead. So 14th group. That means 4th group. Valence electrons 4. So 2 electrons forms 2 chlorines with 2 bonds with 2 chlorine atoms. Remaining 1 lone pair. So remaining 2 electrons means 1 pair. That is lone pair. Fourth one, SF4. Sulfur central atom. Oxygen group sulfur. 6 valence electrons. 1, 2, 3, 4, 5, 6. 4 fluorine atoms forms 4 bonds because fluorine, chlorine are monovalent atoms. Halogens are monovalent atoms. Valency 1. So remaining 1 lone pair. So finally ClF3. Central atom is chlorine. Chlorine valence electrons 7. 1, 2, 3, 4, 5, 6, 7. 3 fluorines forms 3 bonds. So remaining 2 lone pairs. So answer is 1 SO2. SO2 1 and 3, next 4. 1, 3, 4. 1, 3, 4. So answer A. So very easy. If you know the valence electrons or group number of central atom, then easily calculate how many bond pairs and how many lone pairs present on that central atom. Okay, not this.